Okay. All right. So unit 4 was the rational functions. That's the one with fractions. We're gonna do 61, but we're gonna come back to it once we've warmed up a little bit. So for the next one, let's go down to 62. We're just gonna remember how to plug in piecewise functions. And the main thing you have to remember about piecewise functions is that between the equation itself and the limited domain, you have to do your squiggly bracket, which is next to the P key on your keyboard. So for 62, we're going to type in 3 divided by x, and then we're going to do a squiggly bracket. And then we're going to type x less than equal -2. So that's how you can type it in if you don't want to have to use the keyboard on Desmos at all, and you just want to use your computer keyboard. So I'll go ahead and start typing that in. So I've got -3 divided by x. And then my squiggly bracket is right next to the P. X is less than, I'm using the key next to the M. And then I'm going to type the equal to, which is the plus button, equal to -2. And then it just kept the part that I needed. And then for the next one, I've got 2 to the x minus 2, squiggly bracket, and then -2 less than x less than, and then when I type the equal to, it'll make it a less than or equal to 3. And you can type these using your keyboard, which is what I'm doing, but you can also click on this keyboard for Desmos and type them in down here using these inequalities down here. So that's an option as well. I just prefer the actual computer keyboard. And then square root. Anyone remember how to get a square root? You can use the Desmos keyboard, or anyone remember? Oh, you guys haven't learned it. Sorry, I was thinking regular math 3. The other way, I'm going to write this. We're going to write this on our paper because this is kind of helpful. So we're going to write it down here. So a square root like this is SQRT, square root, and a cube root is CBRT. So SQRT or CBRT. So you can get them from, you just type those letters in, and once you're done typing the letters, it will pop up. So you can type it in from the letters and let it pop up, or you can get it from the Desmos keyboard. I'm not a fan of the Desmos keyboard, but that's just my personal preference. So I like to do SQRT and CBRT, but you don't have to do it that way. So I'm going to show you how to get to those from Desmos. So to get to the square root, use the Desmos keyboard, and then I think, hold on, let me move this. Square root is down here. The cube root is a little bit harder to find. You have to go to functions, and you have to scroll all the way to the bottom and use the nth root here. And then just type it in as like a 3rd root or 4th root or 5th root or whatever, if you ever need a different one. But if you type in SQRT, then once you're done typing it, it will put the root in for you. So square root of x minus 2, squiggly bracket, x is greater than 3. So now we can see what that piecewise function looks like, and then what answer choice is the correct one. D. D is the correct answer choice. Okay. All right, how are we going to do problem 63 and problem 64? 63 and 64, what's our method? We're going to cheat doing them. We're not going to do them for real. So how are we going to do them cheating? Say it again. Yeah, so graph the original problem. Graph the answer choices, see which one matches. graph the original problem, graph the answer choices, see which one matches. Okay, this one says to find the inverse. So if we want to find the inverse, what do we have to do? Trade X and Y. Because it's got an inverse, okay? So we're going to take the original problem, we're going to trade X and Y, and then we can compare that with all the graphed answer choices. And Safa, you weren't wrong about the factoring. You were correct, but you were thinking, let's actually do it by hand. We don't want to do that anymore. Yeah, we're done doing math. Okay. Now, what I wanted to do is show you guys how to do 66. This is just like 63 and 64. To get the correct answer, you graph the problem, you graph the answers, and then you'll know which one's right. However, you can't really type this problem in on Desmos so that it looks like this. It's going to look different on Desmos, which is why I want to type it in with you guys. So when we do a fraction divided by a fraction on Desmos, the whole thing's going to look like multiple fractions because Desmos doesn't actually have that little division symbol. All it has is fractions. So what we're going to have is like one big fraction, and then this is going to be a fraction on top, and this is going to be a fraction on bottom. So it's going to be easier for us to kind of write it out ahead of time so we know what it should look like. So we're going to have n squared minus 12n plus 36 over n squared plus 3n minus 54. That's going to be the fraction on top. And then the fraction on bottom is going to be n squared minus 2n minus 24 over n squared plus 13n plus 36. So we're going to have a fraction over a fraction. And when I type it into Desmos, I'm going to type it the same way. So I'm going to do like the big overall fraction first, and then I'll type in the top fraction and the bottom fraction. So I'm going to hit my division symbol, which is like my question mark button. So, and now I'm going to do the top fraction and then the bottom fraction. Okay, so for my top fraction, and again, I'm not using n's because Desmos doesn't really like n's, so I'm using x's. X's or y's. I'll go ahead and use x's. X squared minus 12x plus 36 over x squared plus 3x minus 54. So there's my top fraction. Now I'm going to do my bottom fraction. So x squared minus 2x minus 24 over x squared plus 13x plus 36. Okay. So there's my answer. And then I just need to type all my answer choices and see which one is the same. So my first answer choice is x minus 4 over 9x squared, x minus 10. And that's not it. X minus 8 over x minus 10, x plus 9, which is not it. Answer choice C is the number 1. Now, how do I make Desmos graph a number? Anyone remember? We did this yesterday. How do we make Desmos graph a number? Not set it equal to 0. You do y equals. So if we're graphing this whole thing in terms of x's, we have to do y equals. If we graphed the whole thing in terms of y, we would do x equals. So to get the calculator, to get Desmos to stop being a calculator of numbers and start being a graph, you have to just put a y equals in front. So y equals 1, I just graphed it, and now you can see that it actually is the exact same. So this is one of those problems where it's a division problem. We would have done keep it, change it, flip it. We would have done what Safa said. We would have done a lot of factoring. Every single factor would have canceled out. And then when every single factor cancels out, the answer is 1. And so that's what would have happened with this problem. Everything would have canceled out. We would have got 1 as the result. Yeah. Okay, so the answer for that one is C. Say it again. For like for every division problem, keep, change, flip, factor, that's how we do it by hand. They won't always equal 1, all the other answer choices. The strategy of, if I'm trying to graph a number, putting a Y in front of it will graph the number. Yes, that works every time. Yeah. Okay. Let's see. So we know how to do 68 and 69. Those are solving equations. Can somebody remind me how we solve equations? What do we do to solve equations on Desmos? Exactly, yeah. So the left side of the equation goes for one line, the right side of the equation goes for another line, and we see where they cross. Okay. Let's look at the next page. Ta-da. Let's look at 74. Yeah. Say it again. This is unit 4 and unit 5. Mm-hmm. Sorry, hold on. Unit 6 from 68. Yeah, so when you're looking at where they intersect, you're going to have X and Y coordinates. The X coordinate is the answer. The Y coordinate is what the equation equals when the answer is plugged in. So if you guys remember back in the day and like when you very first started solving equations and your teacher would say, once you get the answer, make sure you plug it back into the equation and see that both sides of the equation equal the same thing, or like check and make sure your answer is right. Does anyone remember doing that back in the day? When you graph two sides of an equal sign and you check and see where they cross, the Y coordinate is showing how you could verify that your answer is correct. It's showing if I plugged my X into the left side of the equation and I plugged it into the right side of the equation to verify for that teacher in 7th grade that my answer was right, that would be me getting the same answer on the left side and the right side. That's what the Y coordinate is. So the left coordinate, the X coordinate is the answer for what X is, and the Y coordinate is you proving you got it right. Does that make sense? Okay. All right. All right, for the next one, it says to find the positive root of 1 over x minus 1 equals x plus 2 over 4. So we're going to go ahead and graph this one. The left side of the equation and the right side of the equation. Oops. Okay. So we have two answers here. Can somebody tell me for 74 what the two answers are? Perfect. So we got 2 over here and we got -3 over there. And if you look for the multiple choice, we only have one option. So which answer are we going to use? 2, because it says to use the positive answer. So -3 is the negative answer, +2 is the positive answer. If it's a situation where you're not writing the answers in yourself, they're going to give you some sort of clue as to which one is the one they want. Or there are some problems where it'll say find the distance between the x-intercepts. So you have to find two x-intercepts to do that. And then you just subtract them from each other to find out how far apart they are. So there are things like that where you still might find two pieces of information to do the problem, but then when you do the problem, you still narrow it down to one answer that you submit. So here we found more than one piece of information, but we were able to narrow it down and then just get one answer. Yeah. All right. I think all these are kind of similar to what we've already done. So let's go ahead and focus on unit 4 for a little bit. So I'm going to let you guys just work on that for maybe, let's say until 1 o'clock. So for about 15 minutes, let's focus on unit 4. So unit 4 starts at problem 61 and it goes to problem 79. So it's the first page front and back. So we're going to start and work on unit 4. And then at 1, we'll do problem 61 together. Okay. So go ahead and work on that. You're doing every problem except for problem 61, and I'll help you guys with that at 1 o'clock. All right, you guys ready? Okay, 61 is kind of a weird problem. It's a difficult problem to cheat on because it's not multiple choice. This is almost as it's not as bad as if it was free response. If this was free response, we would have like completely had to do this, like actually knowing how to do it. But it's almost as bad as free response because there's so many possibilities for what the answers could be. So when you guys take this test, there's going to be multiple choice answers. There's going to be some like click and drag. There's going to be some matching answers, that sort of thing. This problem would have been a problem where you'd have 3 drop-down menus, and each of the drop-down menus had 4 options. And so that makes it so there's like 4 times 4 times 4, 64. 4 times 4 times 4. Yeah, 64 possibilities for what your answers could be, which just makes it so it's kind of like tedious to check all of them. So the fastest way to do this problem is to know how to do it. That is the fastest way. Okay. But I'm not going to go over that because I'm practicing with you guys. Like, how do we do these problems if we don't remember? How can we cheat using Desmos? Okay. So I'm going to show you the Desmos way, but I just want you to know the fastest way to do this problem is not Desmos. The fastest way to do this problem is to mathematically do it the way it should be done. Does that make sense? Okay. Desmos in this situation will actually take more time, but I'm going to go over it with you because if you don't remember how to do it, you're going to need Desmos. So you can see that the problem is in terms of X, but it also has an A, B, and a C. So this is not one of those problems where it has another letter and we can just take that letter and put an X in for it instead, because it already has X's. So we are actually going to take it and we're actually going to type the letter A, B, and C. And it's an equation. So I'm going to type it as 2 lines. I'm going to type, sorry, we're not solving the equation the same way. We're trying to find A, B, and C. I'm going to type it as 1 equation this time. So let's go ahead and do that. No, I still want to type it as 2. Sorry, I was lying. I still want to type it as 2 different lines because I want to see when they equal each other. So just like a normal, just like one of those normal problems where we wanted to see if one thing was equivalent to something else, that's how we're going to kind of treat this, because we want to know when we find the correct A value, the correct B value, and the correct C value. So we're going to type in the left side of the equation as 1 line, and then we're going to type in the right side of the equation as the other line, and we're going to know that we got the answer right when the 2 graphs like match up perfectly. Is that a plus? I think that's a minus. 7x minus 2. Okay, so there's the first one, and then with the second one, I'm actually going to type in the ax squared plus bx plus c over 4x plus 3 and 7x minus 2. Okay, now once you've done this, anytime you use a letter other than X or Y, Desmos is going to ask you if you want sliders. And I told you guys before, sliders just let you plug in numbers for the letter. So that's all it's going to do. And we want sliders because we want to plug in numbers for A, B, and C. We just have specific numbers that we want to plug in for them. So we have these 4 numbers to plug in for A, these 4 numbers to plug in for B, and these 4 numbers to plug in for C. So when it says, do you want to have sliders? My answer is yes. And I want sliders for all of them. So I'm going to press all, and it just did these sliders for me. So what I'm going to do is I'm going to type in the number for each number choice that I have. So for A, I'm going to type in 12. For B, I'm going to type in -31. And for C, I'm going to type in -7. And what I'm about to do for this problem is a very tedious guess and check. So like I said, this problem is easiest to do if you know how to do the problem. That's the fastest way to do it. But if you don't know how to do it, what we are about to do is we are about to type in every combination of this until we get the one where the 2 graphs are on top of each other, because that means that the 2 sides of the equation perfectly equal each other. Does that make sense? Okay, so you do not want to randomly guess and check. You want to have an organized method for how you're typing these in. So what I did when I very first did this problem is I was like, okay, I'm going to keep the A the same and the B the same. And I tried every single value of C. So I tried -7, I tried -3, I tried 13, I tried 16, and I said, okay, the first value for A and the first value for B did not work with any of the C values. So then I moved to the second B value. I kept the first A value, I moved to the second B value, and then I tried all of the C values again. So -7, -3, 13, 16. So the second B value didn't work. Then I tried the third B value and I tried all of the C values. -7, -3, 13. That one's really close. Can you guys see how that one's really close but is not right? Because, so see how you can see 2 colors? If they're right on top of each other, you can only ever see one color. So if you zoom in, then you go like, oh, those are not actually the same graph. Okay. So, and it might be helpful even to like be zoomed in a little bit. Okay. 13, 16. Okay. And then I tried the fourth, -51. And then I tried all the C values. -7, -3, 13, 16. Okay, so what I just found is I tried 12 with every single B value and every single C value. So what does that tell me about 12? It cannot be 12. Okay, so get rid of 12. It's definitely not that one. So then I switched to 13. And then I went through I started at the first B value, -31. And I started at the first C value, -7. And then I kind of went through it again. It's a tedious process. This problem is easier to do if you remember how to do it, but it will get you there. So I want you guys to continue on and do this until you find the right answer. It does not take that long. You'll find it within a few minutes. Now, this test, you can take the time to do tedious Desmos work on this test because there are 60 problems and you can take 4 hours on the test. It will not take you that long to do the test. The regular test administration is 3 hours, 180 minutes. Most students don't even take that long. So you have 180 minutes, and then if you're not done in that time period, they can move you to another room and give you an extra hour. And then I think if you want to take more than that, I think you still can. Maybe, I could be wrong. I've never seen a student actually take that long. So you taking 5 minutes to do tedious Desmos work on a problem will not make you run out of time. Okay, you have plenty of time if you need to do one problem in a tedious way. There is no time crunch on this test. Okay. All right. So go ahead, keep trying the numbers. Did anyone find it? Anyone get it yet? Yeah. What did we get? 13 for A. -43, and then 13 for C. So once you plug those numbers in, 13, -43, 13, you can see that they match up right on top of each other. And it doesn't matter. Let me zoom out. I cannot see any hint of another color, but I can like pick another piece of the graph and I can zoom in. I still cannot see a hint of any other color. So that means they like perfectly match up. Yeah. Okay. So that's it for unit 4. Let's go ahead and turn to unit 5, which starts at problem 80. Okay. So I'm going to delete all of these and click the home button, go back to normal. Okay. So for problem 80, we're going to try to solve it like we normally solve an equation. So go ahead, try to solve it. It's an equation, so we normally graph the left side, graph the right side, see where they cross. Yep, for 80. Graph the left side, graph the right side, see where they cross. Huh? It is almost identical. The Desmos that you see on the exam is in like a super tiny screen though. So it doesn't like expand to see the whole thing because your whole thing is the test itself. So it's like a really small window, which I think is kind of the pain as like when you're working on the test is you wish you could make it like expand to be the whole screen. I don't think so. I think it has to stay kind of small. All right. Are you running into any issues on number 80? They do cross. It's an equation. You're going to be able to solve it, which means they cross at some point. So what issues are you guys running into? Typing it in. So we've got 27. I'm going to type shift 6, 27 to the X. So I got that. And then 9, shift. And then to get X minus 3, I have to put it in parentheses. X minus 3. Otherwise, it won't let me do the minus 3. Okay. Is it very easy to see where they cross? Was anyone able to figure out where they cross? Anyone get the answer? This is one of the problems that on Desmos is almost impossible. It is like, you cannot, for the life of me, I cannot get to figure out where these cross. And it's just because of how these graphs look. The answer, I know the answer is like somewhere over here. They're going to cross somewhere over here, but on Desmos, you just can't really see it very well. This is like the one situation where your graphing calculator is better than Desmos. So what we're going to do is we're going to put Desmos off to the side for a second. We're going to grab our graphing calculators. We're going to graph the same thing. On Desmos, to be able to find the intersection, you have to be able to click on it. On your graphing calculator, you don't have to be able to click on it, which is why our graphing calculator is better to cheat on this particular type of problem. So we're going to go to y equals, we're going to type this in, 27 to the x and 9 to the x minus 3. Yeah, not quite yet. We're just going to hit the graph button, actually. We just want to see it. Now, the only time that the graphing calculator would not be able to give you an answer is if the answer is not in the standard window. So the standard window is from -10 to 10. So if the answer is like -13, you're not going to get the answer because it's not between -10 and 10. If the answer is +21, you're not going to get the answer because it's not between -10 and 10. Does that make sense? So we might have to try a couple times so that we can get the answer if it's outside of that window. Because notice this is still visually based on what I can see. This is just as unhelpful as Desmos was. But this calculator can get it because this calculator can get the answer without being able to see it. Okay. So we're going to find where the graphs cross. So we're going to do second trace and we're going to find the intersection. We're going to do number 5. And to find the intersection, you do not have to be able to see it. You just do second trace number 5, and then you press enter 3 times. Enter, enter, enter. And if it can find it on the screen, it will find it for you. If it can't find it on the screen, it doesn't necessarily mean there's no answer. It just means there's no answer between -10 and 10. You might have to make your screen bigger. Okay. Does that make sense? Yep. Yeah. Mm-hmm. Now, if the reason this problem was kind of difficult was because this did not have a multiple choice answer. If it had a multiple choice answer and you already kind of knew what you were looking for, you could probably go over to Desmos and actually find that point where they crossed. But since we didn't know where that point was, we couldn't look for it. Now, if I go back, we might be able to see that it actually crosses at -6. So maybe -6. Do you know that we crossed there? I don't know. Yeah, it's still, we can't quite tell. The other way we could tell is we could look at the list. So I'm going to pull up the list for both of these, pull up the table for both of these. And if we had multiple choice answers, we could plug in like -6 for this one, plug in -6 for this one. And we could compare the decimals. So I can see that at -6, those decimals are identical to each other. If I had multiple choice answers, that problem would obviously have been a lot easier. I can't do that without the multiple choice answers though. So if you need to solve an equation for specifically, it's only this unit, it has to do specifically with your exponential equations. If the numbers are too big, you're just not going to be able to see it on Desmos. So it's only with exponential equations. The rest of them should be able to do on Desmos, no problem. All right. Okay. I think that we can do these other ones. Let's look at the next one. So this says log base 3 of 8 minus x. I just want to make sure we can type that in. So log is a word. We can type the word log. To get a base of 3, you have to do an underscore. Has anyone ever seen an email address that has an underscore in it? Okay, so that's how you're going to get your base of 3. You're going to type log, and then you're going to type an underscore. And when you type the underscore, your cursor is going to drop down. Instead of going up like an exponent, your cursor is going to drop down, and it's going to be ready for you to put that base in there. So then you're going to put your base of 3, and then you're going to use your right arrow to bump out of the underscore position and back into the normal position. Okay, so we're going to type the word log, and then we're going to use the underscore to drop us down so that we are in that lower position. So I'm typing log and then underscore. It is shift, and it's the number to the right of the 0 key. So shift, there's my underscore. I got my base 3. And then I'm going to hit the right arrow to get out of the underscore. Was everyone able to type that? Okay. And so now I've got 8 minus x. Okay. And I can't see anything right now because I was so zoomed in. So I'm going to hit the home button to go back to normal. Okay. So based on my answers, does it look like my x's are greater than 8 or less than 8? Less than 8? Less than 8. We agree with that. Less than 8. Okay. Now we have to decide if we're less than or equal to 8, or if we're just less than 8. So we can figure this out on Desmos. All we got to do is look at the table. So what I'm going to do is I'm going to pull the table up. I'm going to click on here, pull up the table, and I'm going to get it to go all the way to 8. The numbers less than 8 show up. 8 itself does not. Numbers greater than 8 do not show up either. So only numbers less than 8 worked. Anything bigger than 8 did not. So my answer choice would be X has to be less than 8 for things to show up. Okay. Let's see. I'm turning the wrong way. I think a lot of these are pretty okay with our previous strategies. Okay, so I'm going to let you guys work on that. And then if you guys end up running into more problems you'd like me to do, just let me know and we can do some more problems. Okay, so go ahead and work on that. Let me know. What's due by the end of the period? 1 and 2. What's due by 7 p.m.? 3. Marvelous. We haven't decided yet. Are we getting new problems in class tomorrow? No. No new problems in class tomorrow. Benchmark. Oh, yeah. We've got y equals this stuff. That's the function, right? Okay. Now it says f inverse. So that's not the function, that's the inverse. Okay. So they're saying in the inverse, plug in 8. Okay. So this is the inverse. That means in the function, they must have had 8 as an answer. Does that make sense? Okay, so what I'm going to do now is I'm going to graph this function. So the function is x minus 3 over 3, x minus 3 over 3. And then they're having us plug in those different answer choices. So they're saying for the inverse, if you plug in 8, what do you get as a result? Which means for the original function, what did you plug in to get 8 as a result? That's what that means. So if we look at those multiple choice answers, did I plug in 5/3 and get 8 as a result? Did I plug in 2 and get 8 as a result? Did I plug in 21? Did I plug in 27? Which one did I plug in? Because whichever one I plugged into the original function and got 8 as a result, when I do the inverse, it's going to be flipped. Then in the inverse, I would have plugged in 8 and gotten that as a result instead. So what I'm going to do is I'm going to take this from Desmos and I'm just going to plug in each of these multiple choice numbers and I'm going to see which one spits out 8. So we've got, I'm going to go up here. I'm going to make the table show up because the table is a really good way to plug in numbers. I can plug in 5/3. I can plug in 2. I can plug in 21. And I can plug in 27. So then when you look at them, when you plug in 27, 8 is the output. So that means that they plugged in 27 and got 8. So for the inverse, if you plug in 8, you get 27. So it's this one.